Hello everyone. The topic that I'm going to be talking about it's going to be about traffic management during a cross junction or a crossroads. Um, and so what I'm just doing here is just applying a piezoelectric sensor on traffic lights. Okay, so let's start. Well, here's just an abstract. So, it has been recently proposed and tested that traffic in a large urban region can be modeled dynamically at an aggregate level if the neighborhood are uniformly congested. So, therefore, this project is just to look for a solution in order to solve these problems that nowadays we are facing. And that's the reason why we are using these sensors, the piezoelectric sensors, to solve this problem. Now, just moving on to the introduction part. So you can see nowadays people are just moving smoothly because when they just are using their own cars, their own vehicles, basically it's not a smoothly transportation. So therefore, and therefore people are using like trains, scooters, bicycles, bikes, and so on and so forth, right? Because the reason is that if they use vehicles, so when they are maybe the traffic, they are facing a really heavy traffic, it's going to be really annoying. So, and pretty much maybe if you need to go to work, you will get stuck on traffic lights or on a crossroad. So it's pretty much the reason why we're using these sensors. Now, in modern society, quick mobility is one of the most basic needs. Um, that's the reason why people are not using their own vehicles. So, and they are using subways or scooters, as I mentioned before. Mm, Now, here is the design about these papers, right? Well, first of all, we'll start with the main part, right? So, how is this going to solve? How is going to be the structure of this inconvenience that nowadays we're living? I know that maybe there are many countries where these sensor have been applied, and but there are some other countries where it's not applied yet. So that's the main reason of this project of these papers, right? Well, the piezo electric sensors convert mechanical changes into electrical voltage. This effect can be mathematically represented by the following equation. So you have it right there. Mm, D, which means electric displacement, strain for S, the sensor in this case is the piezoelectric charge constant. It's gonna be D, right? And then we have the dielectric constant at stress, which is T, which is equal to the constant. And then we have the stress and the compliance. Let's see, just let me okay. Just 1 second. So pretty much the car. Well, so this is just a structure, right? So we have the metal plate where the cars are going to be set, or where the cars are going to be located. On the other hand, the other side, we have the lead circuit titanate and the compressing produces electricity, which is going to be sending a message to the the sensor, and And we are going to use also something that we call Zigbee to communicate with the sensors. And automatically we will have the voltage, right, and also how much the weight of those vehicles, and also the amount of vehicles that we have. Maybe we have one, and then behind that vehicles there's another one. Okay, now just moving on to the next part. Well, so pretty much the vehicle is going to be situated or located right here. All right, so on to the next part. Well, here, the principle of working on an embedded piezoelectric generator. So mentioned before, right here, we have the generator. So this car is where the weight is gonna be generated, or like the pressure or force. So pretty much it's gonna be leveling the the weight of the vehicle, and also maybe we have another vehicles behind that, right? Behind this vehicle, and then we have the layer right here, and the piezo electric generator in this part. So pretty much this consists of one or more piezoelectric materials, and these materials are pretty much embedded um, into the ground as layers for the harvesting of energy which is produced by the motion of vehicles. Okay. Um, Now, well, and like on this part, there is something that, well, the pressure right here, right? So the pressure will be exerted by the vehicle movement, and the layers which cause the change in the pressure in this pretty much piezoelectric materials. And then the power, the electric power will be generated once we get the pressure of these piezoelectric materials. Okay, so when it comes to the insulation, it's really, it's not the big deal. It's really easy since there are not too many things that we have to do, right? So pretty much what you need is the form of the layers. So inside the road, I mean on the surface. Uh, so you can see, right? So it's quite simple of doing it, and the wiring process also simple. Implanting the master wires connection and connecting the master circuit to the traffic light is not too difficult. Now, when it comes to cost, right? So as you can see how tiny it is, so it's not too big, just two wires. So we have the negative and the positive, right? So both of them are the terminals, and it's really cheap. The total cost of this project is very less, which is cost effective, because maybe there are other sensors where you have to invest a lot of money um, in order to afford in order to afford this project. But using the piezoelectric sensors are pretty much cheaper, right? And that's the best option that we might have. Um, so including the cost of microcontroller, which pretty much are doing alright. So use and the cost of all the technologies used. Now, so basically on this part we have the crossroad or the cross junction, right? So the vehicles are gonna be like staying or I'm sorry, staying at this part, or just be located on this part, or like any of the side of the four corners or the four sides that we have on this picture, right? And so there's going to be one of the sensors where it's going to be located in like in a distance of 200 meters. Now, the experiment setup, so the best of two piezoelectric sensor will be placed on the road. One is near the traffic light, so which is because we're going to have two sensors, just like these papers, right? But that can be also uh, that's gonna be like up to the person or up to people who if they want to have more or just two. So that's gonna be up to anyone. So one is gonna be near the traffic light, the other one is going to be 200 apart, like, away from traffic light. So in each set of plates, we take about six sensors and we make two rows of these three sensors. So we are just using two rows. We're doing this road and then the other road. Okay, now the printed circuit board plates have thickness 3 centimeters are firstly placed on two tart sheets and the three sensors are installed between these um, circuit boards. Okay. Now traffic control and safety, and then we have the proposed system, right? So when it comes to traffic control and safety, um, nowadays traffic is controlled by automated traffic light. Um, but I mean, but it's just controlled by people, right? By someone, maybe just a police officer who is just given, let's say, given the pass to some other cars, right? For example, when the traffic it's really and extremely heavy, right? So we need maybe not in all in too many well, yes, basically in too many countries. So we have like police officers who are just trying to solve the congested transportation of the traffic. So what they pretty much do uh, is just try to avoid that. But sometimes they can make mistake and also uh, might be some accidents. So the best way to control this is by these sensors, like on a cross junction. Um, we might be thinking, okay, so why we don't have just a roundabout, right? Which is a really good choice as well, but the best choice in this part is going to be this one. Now the results, so the data is obtained and accessed from MATLAB software and stored in text files. And the transportation, well, to the conclusion, hence transportation efficiency is still an active and challenging investigation due to the criticalness of transportation infrastructure being monitored by such a system. And so pretty much that would be it.